Hello, everyone. Thank you for joining us today as we embark on our second workshop around AI questions we get asked most often. Today, we're going to be focusing on data quality from both the product design and even a development perspective. And how do we think about AI product design and ensuring we have the right data quality for these initiatives to be successful? But before we dive in, just going to spend a minute talking about Eighthlight. You may or may not have heard of Eighthlight. We're an agency founded in 2006 of software design and technology professionals. We partner with forward-thinking people and organizations to help them imagine and create elegant, robust, and groundbreaking software solutions to complex problems. We have deep expertise in craftsmanship and experience in software design, development, product, data, and DevOps. And we've worked with a number of clients around a number of initiatives, both large companies as well as small startups. And our approach leverages this cross-functional interdisciplinary team to build high-quality software with product design and development working together throughout the entire process to make the solution work for the user. And today, three of us are going to be talking to you about data quality. I'll turn it over to Pia, our head of product and Gen AI.
Thanks, Jeff. Thanks for joining, everybody. I am here with Eighthlight trying to build out our AI adoption and strategy team and services. So I've got a wide range of experiences across a number of different verticals and industries, most notably teaching technical product management at Northwestern University for their MBA in AI program. So I'm happy to impart some of the things we've learned from our various clients.
Thank you, Pia. My name is Josh Milewski. I'm the design director here at Eighthlight, and I've been working in UX for decades at this point at large companies like Food Network, Google, and Citibank, as well as a number of startups to try to help them be more user-focused and help bring their product design process into a model that makes sense for the team and for the end users. And I'll ask Josh to introduce himself now.
Thanks. I am Josh Milewski, principal crafter here at Eighthlight. I just really like discussing technical challenges, kind of meeting organizations where they are and trying to find solutions that meet everyone's needs. So I've been working in AI for a couple of years now between, different subfields within it, constraint programming, generative AI, and so on. So just happy to talk a bit here about data quality.
Thank you, Josh. As we go through the presentation today, it'll only be about 30 minutes. Feel free to use the chat to ask questions or to bring up points. And we'll start off with Pia talking about product.
As it pertains to data quality, one of the key questions we've gotten asked a lot is how do we as PMs ensure that the data being used actually aligns with the use case, the business objectives, and the end user's needs? And so one of the things that I like to guide and advise folks to think about is obviously the best practice of starting with the business problem, right? Understanding that. And in this case, what you're seeing here is the business problem to solve is I want to enhance my product recommendations for a grocery app. And so one might imagine you can accomplish that in various ways. You might be able to recommend, you might be able to predict based on past behavior, but what is our shortest path to delivering on that business outcome? And so product, much concerned with application development phasing, so too needs to think about their data roadmap in much the same way. And so what is the minimal amount of data that we might be able to source high quality to accomplish that user need? Well, in the first asterisk or spark here, you might be able to accomplish some historical purchase prediction merely based off of having sample data on folks purchasing groceries through your application. That's wonderful. You don't need to necessarily go through the process of centralizing a big data warehouse, identifying new customer segments, predicting highest performing products, and so on and so forth. But let's say that your North Star is to eventually have these personalized product recommendations delivered through some sort of interactive shopper experience. Well, at that point, yes, you must layer on more and more context, higher quality data to be able to accomplish that goal. And so just like we think about iterating on a user application, we need to think about iterating on the data as it expands and evolves to support your use case. So a couple key points. You have your data roadmap, but what are the main things that you'd be concerned about within that data set once you accrue it? One of the themes and concepts you probably have run into a bunch in the Gen AI space is needing expert labeled data. Expert labeled data augments your foundational data. So that purchase history information, you also want to get domain experts saying, was this right? Was this not right? As a shopper, did this work? Was this the product that I intended to buy, or was it not? And really what we're trying to do is tune that model to make sure that it is useful for the user, and that starts with high quality data. And so there is a difference between benchmark data and your test data, your evaluation data, as you go on and start to build more and more complex AI interactions. And so just a nod here that as a product team, you might need to start to explore how to introduce noise into your data, reduce anomalies in your data, maybe resample and bootstrap your data. And there are a wide range of techniques to combat this. The next theme within product data quality is considering the difference, again, in your use case between automation and personalization. And so I already spoke a little bit about minimum data required, and I think design is going to touch on that as well. But really, you don't need your location necessarily if you are just recommending based on past history, purchase behavior. So really taking a closer look at what your data schemas are and minimizing the amount that you need, not just for security purposes, but for quality purposes, reducing that noise. We also want to be mindful about that AI or decision intelligence spectrum. Are you trying to provide an interaction that just says this is the next item that you should purchase? Or are you trying to have an intelligent conversation to justify why it recommended that purchase to you, and so on and so forth? The more interactive you get, you probably need more quality data to support that conversation than you would just recommending an item that you're purchasing. And then lastly, on the technical side, machine learning operations are foundational for high quality generative AI products. We mentioned this phased data roadmap approach. ML Ops gives us the benefit of looking at DevOps best practices as a systematic approach to managing our data and thus data quality. And so as product folks, we're not just concerned with the rollout of features, we also must have prioritization of that technical infrastructure in mind as we're building these systems. And with that, I'll head over to design.
Thank you, Pia. And one of the questions we get asked quite a bit is how can designers communicate to users when data quality might affect the AI's output about data use and alerts for low confidence recommendations specifically. I'll dive into some of that. But kind of building upon what Pia was just saying, it's important from a usability standpoint, not just for AI, but for any design to optimize the input. You want to make sure you get the right data to make the right decision and to follow the workflow that the user is in right now. A good example of a bad use case is usually when you go to the doctor's office and you get like 12 forms. We're asking you for all of this information. Sometimes usually you have to say the same thing like 5 or 6 times, your name and your address, your symptoms, blah, blah, blah. And it's so redundant and so manual. It's a terrible user experience. But then you often wonder, where does all of this even go? Because you're asked for it time and time again. Does anyone ever remember this data or store this data? Why can't there be one system to put all this data into one place, right? And you could imagine the mess it is to actually analyze all that data and to normalize that data that's being asked through different forms and different mechanisms. So it's really important to have very clear instructions and to refine the input structure. So only get what you absolutely need. If you have the information already, don't ask for it again. Provide examples if it's a complex data field and it's not clear how you should actually enter the data. And then inline field validation has become a norm. So as you're typing in something, let the user know if this data looks good or not good right away in real time. And one example, there's many, of course, is from Stripe. They have dynamic form validation. So before you even hit the pay link, you're just in one field. You're typing in a credit card. And it immediately tells you after you typed in all the digits, your card number is invalid. It knows the 002 is not right. So you don't even need to get to the pay button. We don't need to surface an error after you've submitted the form. It's real time. This is not right. Double check your data. This is good usability, but becomes more important as you're sending this data into an AI model. Another thing that a few companies have started doing, I think you're going to see this more often, is contextual indicators. So these are visual cues that reflect the AI's confidence level in the output it's getting. So what you can do is you can imagine color-coded confidence levels: green for yes, we feel this is probably accurate; yellow for medium; red for low, right? Or using percentages next to the results, or a general clarity sentiment on how confident the AI is in the result that it produced. And this was hard to find an example. We've worked on some projects with themes and concepts like this, but there's a tool called Paxton AI that is used for legal documents. And as you might imagine, there have been cases in the past where some lawyers have used outputs from ChatGPT and they've been entirely incorrect, citing cases that never actually happened, right? So this tool helps you create these legal documents, understand what has been done, but then cites examples from where you actually can reference these things. And if something can't really be cited to one particular source, then you get this low confidence answer. It'll give you something as a starting point, but it does not recommend that you actually use this moving forward. But this kind of indicator, I think, as we start incorporating AI, Gen AI specifically, more into the legal system, more into medical documents, it's going to be more important that we have this level of confidence so that the human in the loop can really ascertain whether or not the response is valid, especially when it's something as critical as a healthcare or a legal decision. Explainable AI is becoming a new theme that's even more important now than ever before. So you want to make sure the user understands why decisions were made in your system. But when you introduce AI, it's even more critical. What is this AI thing doing? What is the robot behind the scenes actually, how is it coming up with this decision? So you want to kind of explain in layman's terms why this result, what's going on, and explain what contributed to this answer using natural language, not technical jargon, right? You just want it to be really clear. Because you put in this, we did this. And this also refers to something that Pia mentioned before. LinkedIn is a good example here where you'll get job recommendations, but you don't know why you're particularly getting a job recommendation. So this is very basic, but what it says is based on your profile and search history, you'd be a top applicant, right? So it's giving you some context for why it's recommending a job, or if a number of people work there and it matches your skill set, that could be another reason. But again, giving you that context, and we see this in retail too, because you bought this, or customers also bought this, we surface certain recommendations. This concept is really interesting to me, the notion of adaptive UI, because one of the paradigms in UI is create a consistent experience for everyone so they can quickly learn your system, understand where different things are, and how to use things without having things change every day, right? And there's many degrees of an adaptive UI, but basically the general premise is that it adjusts layout, content, and features to fit the user's needs and preferences based on the data available at that given moment. And we've seen some large companies start to go in this direction. I think it's going to become a little more common, and the notion of chat is going to make this easier to do as well. But a perfect example of this is Amazon. They have a module here that gets smarter over time. So when you come into Amazon the first time, if you've actually never used it, probably a few of you, um, it doesn't know anything about you, but it knows the history of the product you're looking at, and it knows what other people who bought that product bought. So instead of saying other things you might like, it's going to leverage the data that it does have to say customers who bought this item also bought these. So it's giving you some relevance, even though it knows nothing about you. It's taking the information it does know, which is the data on the page you're on right now, that product, to leverage an insight to potentially get you to continue to purchase more. And with that, I will turn it over to Josh to talk about the development side.
Thanks, Jeff. So yeah, when it comes to development, what are the technical best practices to ensure data integrity throughout the AI lifecycle? Just getting started here with some similarities to traditional engineering, also some differences from traditional engineering. So first thing that I want to emphasize is that evaluations are super important. For that, modularity is key. So what I mean by that is kind of breaking down uh, your software into small testable units, right? That's pretty similar to traditional engineering. There are some differences when it comes to generative AI. And if you've attended any of these other sessions, you may have heard me talk more about this. So I do encourage you to attend more sessions. But for now, I will say that when it comes to generative AI, unlike typical traditional unit tests, you can actually reuse the assertions in your test suite in production here for data cleaning purposes. For example, if you've got a health app and a user asks if they took their medication today, you can have a data-backed right or wrong answer to that that you could use in both your tests and in production. And you can be sure of it via assertions. So if the model gets it wrong, you can automatically retry. Also, note that unlike traditional unit tests, the goal here isn't necessarily 100% correct answers. In the context of the health app I mentioned, you probably do want to aim for that, but depending on your exact product, it is a product decision how much tolerance for failures that you could tolerate. And it could also be useful to use LLMs themselves to generate prompts to cover a wide variety of input data for test cases. Another similarity to traditional engineering is observability in general. For example, tracing is something that's quite useful in both traditional engineering and in generative AI. This is the concept of organizing logs into structured user flows. So that is to say, collating logs from an entire process like user checkout. So when you go and try to debug it, you can actually view events as things change throughout the user's interaction with software. When it comes to AI, tools like LangChain and Langsmith can be used for the same purpose, capturing an entire user session in a human readable way. The goal here is to reduce friction in analyzing tests. So between tools like that, you could also build a simple dashboard, for example. So if you've got a bug in your model output, you make a change, then you can more easily see, our incidence of that bug going down in tests and in production. You're kind of on the right track. As for some differences from traditional engineering, so I talked about evaluations. They're of course important traditionally and in Gen AI, but the metrics themselves are a bit different in AI. So, we're kind of asking the question, does the LLM produce the output we expect, right? So we can have assertions built into our tests, those same assertions in production. That'll help produce better quality data. And with that, you can add that back into the fine tuning for your model. Just as important as model evaluation is human evaluation. And the truth is, you'll never get away from human evaluation. There's no such thing as a free lunch, right? But while you might start off with human evaluation on everything that you do, right? Every output as you're beginning your training or fine tuning, over time, as your metrics improve, you might be able to switch to just sampling your data. But again, you'll never really get away from it. So, it is important to kind of, we recommend keeping it simple at first, sort of just saying, is the output good or bad? So if a human is evaluating something, make the evaluation binary to start. There are more advanced techniques like active learning or consensus voting, but there's no need to use them just to get started. And we really also need to decide if we are going to be asking just whether the output is good or bad, we need to know what good looks like, right? We can gather data, but how do we determine what's good? And what direction should the model move in over time? Is a false positive worse than a false negative, and so on? And just to illustrate that point a little bit, I've got kind of a chart here where we might rank false positives or FP on that one column and false negatives or FN by severity for different tasks. It kind of illustrates how, depending on the task, a false positive and a false negative can be very different things. Just to zoom in a little bit, if we look at fraud detection and pre-crime detection, the consequences of a false positive in fraud detection are, you might lose a sale, right? Not a big deal. The consequences of a false positive for pre-crime detection is like unjust imprisonment, right? So it's just a huge difference. We really need to focus on, what is good and what is bad, and tailor it specifically to the task and the output that you're trying to measure against. So, yeah, data accuracy. I believe, Pia, you might have mentioned something along these lines, but a specific example here is, there was a case earlier this year involving Air Canada. So a customer used their chatbot on their website. That chatbot provided incorrect information about customers' eligibility for a refund, and Air Canada tried to fight that, but was ultimately held liable to honor what their chatbot said. So the direct financial impact of that was probably pretty small, but the reputational impact was potentially huge. So it's kind of just to illustrate the point that, when it comes to data quality and data accuracy, there is a potential liability vector here as well. Whatever information you're putting out there under your branding, it's still your information. So all of these techniques that we're talking about, besides just improving your product, could also, help you avoid issues with liability, right? And yeah, so ML ops. Okay, yeah, Pia, you did mention this for sure. So yeah, just the last thing I kind of want to touch on here is ML ops. This is broad range of techniques. It's borrowing from DevOps. But we're treating data sets and models as first class. So it's kind of an expansion of DevOps to include data science and domain expertise. For example, you might want to evaluate the detection of model drift, which could show up as, for example, you might deploy a service with a fine-tuned model. You're meeting all of your performance metrics the first week, and then a week later you see everything drop by about 5%, and then you see that again the next week, and so on. Uh, Rather than model drift, it might be better to kind of call this environment drift. And what could be happening here is that the product was a good fit for your market and your users when it launched, but as users began to interact with it differently, your model might no longer be the best fit for that environment. So you need to kind of continuously monitor this and feed that data back into your fine tuning, for example, or whatever you're doing with it. A big barrier to MLOps adoption that we see is that it requires collaboration between data science and operations and requires a culture of continuous improvement, which often requires significant changes in organizational culture and priorities. But the key thing to keep in mind is just overall, between all of this and MLOps, is that successful data quality is not an overnight or individual process, but it requires organizational commitment and time and effort, but it is worth it. And with that, I will pass it over to Jeff to see if we've got any questions or comments.
Thank you, Josh. So yeah, hopefully this was useful to you all. Do you have any thoughts about any of the material we covered or any clarifying questions, comments? Feel free to use the chat. And it doesn't seem as though anyone has any thoughts. If you do have any thoughts after this, feel free to shoot us an email. We would love to work with you on some of these problems. And I hope you all have a wonderful rest of your week. Thank you, Pia. Thank you, Josh, for your help. And we will talk to you all soon. Take care.
Thanks so much.
Thank you.